So I'm a researcher at the IBM Almaden Research Center in San Jose, California. My accent is not American, it's Canadian if you're wondering, but that's okay. So one of the, as a researcher, one of the greatest things you can do is essentially do something, build something, and then have someone use it and deploy it. So, I thank Simon in inviting us here and working with him over the last year or two to get Climb and Bear up and running has been, again, it's one of the things that us researchers sit around and we hope happens, right? Because, we want someone to use what we're building. All right, so what I want to talk about now is a little bit of, at Almaden Research Center, typically we're the ones, spewing out the technology and sort of forcing others to learn it and adapt to what we've been building. And I would say that what's happened in the last few years with cloud and open source and these types of things, it's sort of gone in reverse. We're kind of the ones now having to, we are still creating the technology, but I would say every company is also having to absorb all the technology. And I've heard this referred to some degree as a technological sonic boom. The technology is coming at you faster than you can absorb it, and your organization is essentially just getting overloaded with that information. And so, while I think it happens to everybody, the people in the technology area and the researchers, it's also happening to us now as well. And we're having to absorb all of this technology and to keeping up, it's been quite challenging. So what I want to talk today about is storage in the cloud, what's being used in Bear and Climb. Spectrum scale, known as GPFS, so just to give a brief introduction. It's been around now for literally since the 90s, so it's been it's like a 20-year journey. I have not been on the whole journey, needless to say, but at the same time, it's been a product, I think now for 15 years. It's really branched out. It started in HPC, still in HPC. That's where we like to be, but at the same time also branching out into many other areas as well. And cloud is one of those areas, of course, because we all believe that whether in HPC or it doesn't matter what industry you're in, it's migrating into the cloud. And so then providing the level of storage in the cloud is also becoming important. And one key part about spectrum scale that I think is sort of key and interesting and unique among many of the storage platforms you could go out and buy today is that it's research driven. So a lot of the new technologies, the new features, the directions is all led by the research team because it's hard. And we're happy to keep involved and keep pushing the limits forward. So one of the things I've been doing there is essentially trying to avoid islands of storage. I would say if you summed up my research to date, that would somewhat classify that. You can always sort of tell, I would say, how either, maybe overloaded, but how mature a technology area is on how many islands of storage it's creating in its environment. Because typically, the science and the compute side, drives everything, and then all of a sudden storage struggles to catch up, and eventually you end up in a situation where you may have millions of islands of storage just scattered everywhere, and then it takes time to figure out how to integrate them all. And as we said before, with integrated storage, and it can share data across your organization, across the world, essentially. And that's the key to collaboration and science. So this is what we try to do, and constantly it's like stamping out, heads at some game or something to that effect. Gophers, they keep popping up here and there, and so now in the cloud especially, that's something where we've been trying to get involved and figure out what we can do and provide global collaboration and access to your data. So with Spectrum Scale, I've classified a lot of the work we've done into we're on the cloud, in the cloud, and under the cloud, meaning supporting the infrastructure as well. And so I was going to go through some of the areas that we've been working on in the last few years in those three different areas. All right, so in the cloud. So running in the cloud sounds simple, But unfortunately, what happened was that just creating storage systems, providing an API, people read and write data. Unfortunately, that's sort of going away. If you only provide that and you don't integrate into the different infrastructures that are out there and provide the right way of managing and accessing your data, no one's going to use you. So this is where we've been looking at supporting a variety of different protocols and APIs in order to ensure, again, the greatest amount of collaboration and access to user data. So, the easiest thing to do is essentially just deploy your storage and now put it in your clouds, put it in your VMs, and move forward. And so, today we can do that relatively straightforward. Climb is doing this, and you can access your data that way and do your HPC cloud that way. But that's pretty much the end of where, the straightforward integration was. So one of the key things was adding in multiple protocols. So NFS and Samba support, these are older protocols that have been around forever, and accessing storage. POSIX, needless to say, is one of the standards out there that continues to dominate. But in the last few years, HDFS, which people think is a file system, and it is, but it also is an API and something that you need to support if you want to provide analytics on your data. But as well, back to object storage, people also tend to think that object storage unto itself is a thing and you buy it separately, and it's true, but at the same time it is also a set of APIs, most notably nowadays the Swift API and the S3 APIs. These are simply APIs that you can use to access any storage system. You don't have to just access Amazon or some other OpenStack system with them. And so supporting those APIs was, again, a critical part of, branching out the access to the data and providing new use cases. And most notably with cloud and object, these are the protocols people are using in the cloud. These are the protocols that need to be continued to use, whether you deploy it on premise or in a cloud or wherever they are. The other protocols that are out there just are not web friendly. They don't have the right security. They don't have the right authentication. They don't provide essentially what is needed in order to globally share your data. So that was an important part of our journey, again, is to support object protocols. Manila is another project within OpenStack. So as part of OpenStack, there's about 17,000 projects. You can sort of look online. Some of them live and die on a daily basis, and some of them sin to endure. With Manila, the goal is to provide a standard way of accessing file shares in your cloud, in your OpenStack cloud. So it's essentially a management API that's been standardized and allows users and clouds to create and manage their storage system without needing to know the guts of the actual storage system they're using. And so this is something we've worked hard to implement. And again, you'd think, well, why is that a good thing? Well, the easier we can allow people to integrate our software and deploy it and use it, it's the better, right? So we don't have to keep teaching new protocols, new ways of managing over and over and over again. And now containers. So it was brought up a couple times throughout the day. But I think as soon as we sort of got comfortable now with VMs, VMware has been around for over a decade. I think the saturation of VMs into the enterprise data center is pretty much complete. Of course, a new technology comes around and now questions whether or not VMs was even the right way to go. Now, this is still in very early stages. Needless to say, this is something that is just slowly emerging and will take time, I think, to flush out where it ends up. But at the same time, containers are providing a really interesting way now of virtualizing your data center and providing access to but then also introduces new methods that need to access your data. But the key basic item with containers is that they're standardizing the infrastructure where it stores all of the unique parts of your applications. And what that means is that, again, back to somebody mentioned earlier about reproducibility and sharing of data sets. Well, if you can take a container and you can standardize all of the Python libraries and all the little libraries that you need for your application, you can then take that and share it with any number of researchers around the world and try to, again, at the same time, reproduce results in a variety of different infrastructures and share what you've built, with other researchers. Because, as I think we've all probably experienced, you run on one supercomputer on one side, take that, same app and try to run it on some other site just without any changes. Good luck, right? So it's not good. This allows us to take standardized forms of applications and run them anywhere without needing to, request new packages to be installed or new infrastructure. So, I list HPC and scientific computing right at the top. I don't think they're driving the use of containers, but I think that it is going to have, as I just mentioned, a prominent impact into the area. The bottom one is probably more of the common use case today. Born on the cloud, companies are using them to load balance their work across VMs inside Amazon and other clouds out there. But they're all providing a lot of different features for continuous integration of your products and many other areas. So what's also been interesting is, I would say to some degree, under some people's noses, without even knowing it, an entire industry has formed up around containers. There's not to the same degree that VMware really dominated, I would say, the VM market in many ways. In some ways, Docker is to some degree the company that is driving and the most successful, but at the same time, there's a variety of open source and other companies forming up around and competing with, and you can see that it's really just one of the set of technologies that is providing the container engine that's out there, and it's really too early to say where everything is going to go. But what all of these infrastructure means, again, is integration and adapting to how storage is being used across this entire ecosystem and at each level of the ecosystem. So what we're doing right now is building a standardized service that will create and provision and manage storage for the entire ecosystem that's out there. That includes Kubernetes, which is coming out of Google with the Docker work, and there's other companies out there like Mesosphere that are also providing systems. And so by providing this standardized service, that will allow users and administrators to create and provision the storage, again, in a standardized way for the framework that they want to use. So if you're using an OpenStack environment, you can use Manila to provision your storage. If you're using Docker and Kubernetes and this type of environments, you can now use this type of service to do that, again, without needing to know the details of the underlying system. So just briefly, with Spectrum Scale on Docker, there's a lot of advantages as well. What it enables is, as you can see, cross-host access. So just simply today, as you would launch bare metal machines or VMs and access your data across the entire cluster, you can do the exact same thing with containers. But one of the key advantages here, again, is that it is a container. It is locking the user into a little box inside the operating system. What that means is that they are isolated to the data that they can see. Even though you can give root access, for example, to users inside a container, you can prevent them from taking over your entire cluster. So the security in terms of multi-tenancy and allowing all of the different groups to coexist on the same infrastructure has really been increased with container technology. As well, and one of the key benefits that we like is the performance. So storage performance is unaffected, and it allows you to get bare metal performance as well. And that this can be done, again, on top of your virtual infrastructure on your VMs with OpenStack, for example, or you can just do it on bare metal. All right, so under the cloud. So this is actually supporting the infrastructure of the cloud. It sounds, to some degree, easier than it is. There are, again, easy to access data from the cloud, but now actually supporting the infrastructure, which is going on with Bear, becomes another challenge. Yet again, there is a need to integrate with standard mechanisms for provisioning and managing storage, which is what OpenStack Cinder project is for, and being able to do that again across multiple protocols. So that's something we've been doing for quite a while now. And in the future, the same thing's going to be happening with containers. Today, again, I would go back to my thought of the maturity of an organization really is about how many little islands of storage they have. With Docker right now, it's all spread out across your local disks, and everything is quite, I would say, kind of a mess, if one way to put it anyways. So moving again, just like virtualization did with VMs, moving containers back into the shared storage architecture, leveraging and being able to share your storage across the entire system is something that we'll be working on as well. And finally, in the cloud. So, here what I'm referring to is there's a movement to say, well, we're not going to buy any hardware. We're just going to buy services, and we're going to run everything in a virtual environment. As I think was stated as well, as I would say to some degree, as much effort has been put in, there's a long way to go in order to achieve this truly on clouds, or existing clouds like Amazon and others. And so the goal here is to provide the same large-scale storage infrastructure, but also the performance and the requirements and the integration that's needed, just as if you were running on your bare metal supercomputer or your local cluster or other system. And so the goal then, is there's 4 listed here. There's many more out there as well. And so every single one of them now becomes a challenge in, again, additional layers of integration. So in this environment, from a storage system point of view, we like to know what's down below. And from an engineering point of view, we like to understand and control, where we work. This is sort of gone now. In the virtual infrastructure, many of these clouds won't even tell you what's under the covers. They won't tell you what technology they use. They won't tell you why they do it. They don't tell you basically anything. What they do instead is describe storage with respect to features. This is available. This is slow. They give it these general abstract terms. And so that's sort of the environment that we have to work within and then provide the same level of services. But at the same time, we as developing Spectrum Scale, it's a general software storage platform. It runs on anything, and we've already sort of lost control. So it's actually not that bad in the sense that I think that all the storage software is moving in that direction. We don't know who's running it. We don't know where they're running it. We don't know what hardware they're using. And we have to plan and adapt and support all of those environments. So that's why I put their storage is now squares and boxes, and that's literally true. I mean, we have no idea. It's just a bunch of little abstract things that we have to cobble up and provide. The second one, I would say the second issue in this area is around, I didn't ask Simon how long he spent getting Bear Cloud up and running, but I assume it's in the order of weeks or months. At the minimum. If you go to Amazon and say, well, I want to run a job for 1 hour and I want to have 1,000 nodes, and if I told you it's going to take weeks and months to get that up and running to do that 1 hour, I think you might be somewhat upset because you're paying for that entire time. So I don't think that you want to pay to Amazon money for weeks and months just to run a job that will take literally 1 hour. So at this point, we're in this item now where on-premise and building clouds in data centers, we've spent a few months setting it up, but then it lasts years and years and years. Here we're in the reverse scenario. It still takes the same amount of time to configure and set up, except you want to run it for an hour, a week, maybe a month. The main advantage in many of the cases for HPC and for large-scale data and compute access in the cloud right now is to say it's a bursting scenario. They don't have the resources on their data center. They need extra resources. They want to get into the cloud quickly. They want to run their jobs, and they want to get out. Well, that cannot take a month to set up. So how do we provision here in this example, 1,000 node cluster, 10 petabytes of storage, provide you all the infrastructure that you're looking for, but then tear it down within an hour. That, I think, is a really big challenge that, again, is going to take a lot of collaboration across different teams and companies in order to achieve. And I think that is it. So finally, I want to say we are a research center. We do bring in interns and students every summer. Our last summer, we had one from Imperial College, so it's actually quite easy to come in from the UK. So always interested in anyone that is looking at storage technologies and interested in working in that area. So other than that, I wanted to say thank you.